Hello, I'm Alex from the International Department of Beijing Challenge Group. Today, let me share the rapid adjustment scheme for animal intestinal health application for thermostable lactic acid bacteria UC products. Probiotics has been a hot topic in industry in recent years, including researching on human nutrition, animal nutrition, and immunity. The well-known probiotics include lactic acid bacteria, bacillus, yeast. For the livestock feed industry, we only take the production market share of probiotics in different kinds of animal feeds in the world in 2016 as an example. The lactic acid bacteria accounts for half of them. In addition, in the past 2 years, China has banned resistance, and the lactic acid bacteria are an important part of the scheme of non-resistance breeding, intestinal health, cost reduction, and efficiency increases. As a live feed preparation, bacillus is rich in enzyme production. Because there are sperms, it has natural thermostable ability. Yeast produces more microbial proteins. We often use them as yeast byproducts and deep processing products. But the temperature tolerance of yeast is poor. Both of them are passing bacteria intestinally. Lactic acid bacteria, which can produce lactic acid and lactic bacilli, has good antibacterial properties. At the same time, they are resistant bacteria in the intestine and have strong colonization ability. Compared with these first two, they have natural advantages. However, the obvious advantage of lactic acid bacteria are often limited in application. I summarize the reason as follows: the strain selection, cost, and stability. Therefore, applying any kinds of live bacteria preparation, the first thing we should consider is its safety. In other words, we should use the bacteria allowed in the National Feed Additive Catalog. Next, we will consider probiotics performance. Good probiotic performance is the key to affect the use effect. For production enterprises, due to its poor stress resistance and heat resistance, lactic acid bacteria have certain technical barrier from strain screen to post-treatment process, and the production cost is relatively high, which greatly limits its wide application in practical breeding. How to select a good lactic acid bacteria? How to make the use cost of a formulator more reasonable? How to make the live lactic acid bacteria go through the granulation, expansion, and other links in the feed processing process, from the factory to the warehouse without loss or reduced loss, and how to ensure that the animals go through the mouth, esophagus, and stomach from the moment of the entrance. It can still reach the intestine with a certain amount of effective viable bacteria to exercise its biologic function, so as to improve production performance, which will be the focus of our discussion today. In addition to safety, adhesion is another important point for lactic acid bacteria. Let's first look at the lactic metabolism curve. Compare with the strains isolated from the unimported product. The lactic acid production capacity of glue-coated excellent C lactic acid bacteria is equal to that of the other strains, up to 11 grams per liter. With the production of amylase and lipase is also excellent. We dedicate Salmonella, Anaphylococcus, E. coli KAA, and K99, and observed that the pure-coated excellent C lactic bacteria product has good antibacterial performance against the above 4 harmful bacteria. It can be seen that there is an obvious bacterialistic clue because the surface of a pre-coated lactic acid bacteria can exist in peptidoglycan, polysaccharide, and the protein structure. It plays an important role in the adhesion and colonization of the intestinal epithelial cells. Let's take a look at the other caused problem we are concerned about. Due to the poor tolerance of lactic acid bacteria, we naturally choose to wrap it. The traditional coating form is to completely wrap the core material such as bacteria powder with wall bacteria such as protective agent and accessories. Just like we make dumplings or mix bacteria powder and the protective agent in the form of embedding and granulating. Such products are often difficult to achieve a high content of live bacteria, and its stability is still not well guaranteed. The other is lyophilized powder with a relatively high production cost. This kind of product has higher number of live bacteria and have certain improvement in stability compared with the traditional coating. However, its production requires a vertical freeze drying process with high energy consumption, and the cost is under certain pressure. What can avoid those two shortcomings is that the microencapsulation fold coating process is to be launched today. Through it, we can get lactic acid bacteria products with relatively low price and high product stability. So, what is the microencapsulation pre-coating technology? A small amount of microbial seed cells are wrapped in microcapsule and then fermented. In other words, microorganizations grow, reproduce, proliferate, and metabolize in the small house of microcapsules, so as to be obtain a lactic acid bacteria products with high activity and high density. As you can see, the picture on the left shows the empty capsule before fermentation, which is relatively transparent. On the right is the state of capsule after fermentation. The black shadow is heavier, and the part is where the bacteria grow. Let's look at those group of scanning select microscope picture, which will have a more intuitive effect. On the left side, there is small microcapsule before fermentation. The bubble on the surface of a microcapsule after intermediate fermentation proves that it is full of bacteria. On the right side, we cut it and see structure inside. The small particles are the bacteria of lactic acid bacteria. There is a process of coating before fermentation. What is the application mechanism of those special coating process? What effect can we get? We use the colony effect of microorganisms. The so-called colony effect is a mechanism for the regulation of bacteria colony behavior. Microorganisms release a special signal molecule to the surrounding environment during production. When the signal molecule reaches a certain degree, bacteria cells feel the density change and start the expression of some special gene to control colony behavior. The fluorescence picture on the right in the figure shows that green fluorescence increase and fall 6 and 12 hours during the fermentation process, indication that the bacteria grow rapidly in the capsule. Use the population effect. The lactic acid bacteria in the capsule can be full, and the polysaccharides and the proteins on its surface are viscous, which makes the bacteria adhere to the intestinal epithelial cells better and have better colonization ability. But it will also affect the testing process of our quality evaluation. The following is the processing of common microbial detection, include sample weighing, shaking table dilution, gradient dilution until the final plate coating. culture and colony coating. For the front-coated lactobacillus product, because the production process wraps a capsule for him, it will go through a capsule breaking process during sample processing. Because of the high number of living bacteria, the bacteria in the capsule are closely connected. We need to disperse the cells through special treatment such as centrifugation and hydrolysis in order to obtain more accurate detection values. When I mentioned the probiotics performance just now, the first one is the proliferation rate. I also show you the growth of lactic acid bacteria in the capsule with pictures. Now, do you use the data to see how fast it grows? Comparing the strands isolated front-coated lactic acid bacteria products with imported products, we found that growth rate is better than the imported products. The generation time is 19 minutes, while the generation time of E. coli is 20 minutes. That is, if the front-coated lactic acid bacteria products are on the same starting line, they have ability to PK with E. coli, so as to gain an advantage in the position competition. Everyone cares about the quality. Can it be wrapped? We store the imported product and the front-coated lactic acid bacteria products in the artificial simulated gastric juice with pH 1.5 at the same time. It can be observed from the microscopic examination that the capture of the imported product has been invisible after treatment for 3 or 6 hours, while the front-coated capture still exists. Since the capture exists, the microscopic examination only means that the capture has not been broken. But is the bacteria inside alive? We then plate culture it and grow it to show that it's alive. The special chromatic molding is used here. When the colony grows on it, the color of the molding will turn black. Seeing that the growth of imported products is very limited, and the in-front-coated products are dancing and warm, and the culture molding is black, it proves that it can be wrapped under acidic condition, and the encapsulated bacteria are still alive. Let's look at the treatment of simulated gastric juice with different pH value for 3 hours and bile salt with different concentration for 8 hours. Compare with imported product. Pre-coated excellent UC 100 products still have high variability. Okay, now see if it can be released. We first treated it in the artificial gastric juice for 3 hours, then transferred it to the artificial intestinal juice for 1 hour. Then sampled and tested it every 15 minutes, and the results show that after 45 minutes, the release rate tended to be flat, basically about 80%. In the figure, it can be seen that 80 to 90% of acetic acid bacteria will be free from the capture in the area of 45 to 60 minutes, which proves that it is released from intestine. Next, we are most concerned about the problem. Have you really withstood with the high temperature? We treated the commercially available free-dried powder at 80 and 19 centigrade for 2 minutes and 5 minutes, and observed that the number of viable bacteria still decreased significantly. Then the bacterial powder and the pre-coated products produced by the same strains were evaluated under the condition of high temperature and a humidity of 75 centigrade and 85 centigrades. The results show that the pre-coated lactic acid bacteria have high tolerance activity. It's still the same strains which is prepared by two processes. Observe its store stability at room temperature. It's found that lactic acid bacteria treated in the front package still have up to 80% activity when stored for half a year, 1 year, or even 1.5 years. The above is lactic acid bacteria UC cereal products produced by the front coating process, which have the characteristic of the good probiotic performance, high content of live bacteria, and strong stability. What is the effect of such products in the actual application process? Let's first look at the effect on the regulation of intestinal flora and the diarrhea rate of pigments. We take E. coli as a marker of harmful flora, and the lactobacillus as a marker of beneficial flora. It can be seen from the chart that adding different concentration of pre-coated UC100 products can increase the number of lactobacillus in circle and clone, reduce the number of E. coli, regulate the flora, and help the dominated flora occupy the position in the intestine. Next, let's look at the second experiment on pigments. By adding different dosage of UC100 lactobacillus products, the daily gain of pigments was significantly increased, and the feed-meat ratio was significantly reduced in the first 40 days, which was comparable to that in the antibiotic group. The diarrhea rate can be improved in varied degrees after adding lactic acid bacteria. Let's pay more attention to the intestinal health of a boiler. It can be seen from intestinal slice that antibiotic group make the villi of a boiler's small intestine thin, and the top of intestinal villi is damaged, which is not complete. The small intestinal villi in the front coated with lactic acid bacteria group are regularly strong and complete, and the top is not damaged, indicating that it can strengthen the intestinal barrier and reduce the occurrence of intestinal inflammation in boilers. Solving production problem is not what one product can do, but often through a combination scheme. We also try to find some additive that can match with the pre-coat UC products to achieve the purpose of reducing the background and increasing the efficiency. The specialty of challenge group is enzymes preparation. So we combine the front-coated UC product with NSP enzymes, protease, and the glucose oxidase. After several similar blood tests, it was found that all the combined products added with UC1000 have obviously effect on the improvement of the feed rate of the boiler in the whole process, which is closest to the production performance of adding antibiotics. After accumulating some experience in this experiment, we then explore that in addition to combination of UC1000 and the grab oxidase, adding another functional enzyme preparation, quenching enzyme, can still achieve the lowest material ratio, the best European index, and the highest economic benefits. After the small group test, we apply the technical scheme previously schemes for the bacterial enzyme combination to the large group test to further verify the effect. In a boiler farm in Liaoning, compared with the product group of other manufacturers, the feed to plant ratio and the production performance of boiler coated with a combination of UC and the glucose oxidase have been significantly improved. The following is a probiotic feedback from afar. The bacterial enzyme binding group was also verified in laying hens. On the basis of a challenge, the original laying hens composed enzyme 8308, which strengthens the 5 billion pre-coated lactic acid bacteria. The results show that the overall egg weight of number 2 and number 3 laying hens and with the bacterial enzyme binding group increased after 340 days of age compared with that of number 1 laying hen sold on the market. While that of a product sold out on the market showed a jaw-drum trade, it showed that this combination has a good effect on the improvement of laying performance in the later stage of laying. The above introduced the characteristic of a good probiotic performance: low production cost and strong stability of fluorine-coated lactic bacteria. It can significantly improve the intestinal health of animals, reduce the incidence of diarrhea and enteritis, and improve the production performance of animals. It suggests that if it used in combination with additives such as enzymes, essential oils, or other microorganisms, the additional amount of UC100 is 200 to 300 grams per ton, and the additional amount of UC1000 is 50 and 100 grams per ton. Among them, the combination with glucose oxidase and quenching enzyme has the best effect. I will introduce it here today. Thank you, and see you next time.